There are 4 million Ford F-150s on American roads right now, with engines quietly destroying themselves from the inside. Not because of bad driving, not because of cheap fuel, because of one microscopic problem that Ford's service manual never mentions, and that every authorized dealership in America is financially motivated to ignore. The fix costs $3. It takes 20 minutes in your own driveway. And if you do it before your F-150 hits 100,000 miles, you will likely never need an engine rebuild for the life of the truck. If you've already passed 100,000 miles, stay with me. Because what I'm about to show you works at any mileage, and the results after 200,000 miles are almost more dramatic than at 100,000. This is not a product ad. I'm not selling anything. What I'm about to tell you is freely available information that the $47 billion automotive repair industry has spent decades making sure you never connect into a single sentence. The Ford F-150 has been America's best-selling truck for 47 consecutive years. Ford knows how to build a truck, but here's what Ford also knows, and what they will never put in your owner's manual. The 5.0L Coyote engine, the 3.5L EcoBoost, and the 2.7L EcoBoost, all three of Ford's most popular F-150 engines, share one identical vulnerability. A vulnerability that doesn't show up in your first oil change, doesn't show up at 50,000 miles. But by 80,000 to 100,000 miles, it has already caused damage that no oil change can reverse. It's called boundary lubrication failure at the piston ring interface. Here's what that means in plain English. Your engine oil does an incredible job lubricating your engine under normal operating conditions. But there are 3 moments in every single combustion cycle where the oil film between your piston rings and cylinder walls becomes too thin to fully protect the metal. At the top of the compression stroke, at the moment of combustion, and at engine startup before oil pressure fully builds. These 3 moments happen thousands of times per minute. Every minute your engine runs. Every day you drive your truck. Each moment causes metal-to-metal contact so small you can't feel it, can't hear it, can't measure it with standard diagnostic equipment. But over 80,000 to 100,000 miles, those microscopic contacts add up to something you absolutely can measure. Lost compression, increased oil consumption, and the beginning of the slow decline that ends with a $6,000 engine rebuild or a $12,000 engine replacement. Ford dealers know this decline is coming. That's not cynicism, that's a business model. In 1943, the United States Army ran classified materials testing at Aberdeen Proving Ground in Maryland. Engineers were searching for a compound that could protect tank and aircraft engines operating under extreme heat and pressure in the deserts of North Africa and the frozen conditions of the European theater. They tested 60 different compounds. One outperformed every other substance in the entire program, not by a small margin. The declassified reports show it reducing metal fatigue by up to 80% compared to standard military-grade lubricant. The U.S. Army adopted it immediately. Sherman tank engines were treated with it across 3 theaters of war. After 1945, this compound quietly moved into American industrial manufacturing, aerospace engineering, and military vehicle maintenance programs. It was never removed from those applications because it never failed a single performance test. But it was removed from consumer automotive service training in the late 1970s. Not because it failed, because it worked too well. The compound is called molybdenum disulfide. The chemical formula is MOS2. Here is why it works in a way that no liquid oil additive can match. MOS2 is not a liquid. It is a solid crystalline compound with a layered hexagonal plate structure. When these microscopic plates, each approximately 1 to 2 microns in diameter, contact a metal surface under heat and pressure, they do not sit on top of the metal the way a coating does. The sulfur atoms in MOS2 bond chemically to the iron atoms in the steel surface through a process called tribochemical reaction. The plates become part of the metal itself. They fill the microscopic valleys in your cylinder walls and bearing surfaces and create a crystalline layer that is harder than the underlying steel, but has an extraordinarily low coefficient of friction. The coefficient of friction of MOS2 is 0.03 to 0.05. The best full synthetic motor oil sits at 0.08 to 0.12. That's a 60 to 70% reduction in friction, specifically in the boundary lubrication zone where oil cannot reach and where every other additive in your engine has already failed. A peer-reviewed study published in Tribology International in 2018 measured engine wear in test motors treated with MOS2 versus untreated controls running identical synthetic oil. After 200 simulated hours of operation, roughly 12,000 miles of mixed driving, the MOS2 treated engines showed 68% less cylinder wall wear. The results have never been contested by any independent research group. Now, here is why this matters specifically to F-150 owners more than almost any other vehicle on the road. The 3.5L EcoBoost engine, Ford's most popular F-150 engine since 2011, operates at significantly higher cylinder pressures than a naturally aspirated engine. Turbocharging forces more air and fuel into the combustion chamber, which means higher combustion pressures, which means greater stress on the exact boundary lubrication zone where MOS2 provides its most dramatic protection. Ford's own engineering data shows the EcoBoost cylinder walls operating at pressures up to 2200 psi at peak combustion. At those pressures, even full synthetic oil is being compressed out of the contact zone between the piston ring and cylinder wall. This is not a design flaw, it's the physics of turbocharging. More power requires more cylinder pressure. More cylinder pressure means more boundary lubrication stress. More boundary lubrication stress means faster cylinder wall wear unless you address the one thing that oil alone cannot fix. There's a fleet manager in Texas who operates 18 Ford F-150s for a regional logistics company. His trucks average 40,000 miles per year, the same annual mileage that would destroy most consumer engines within 6 to 8 years. His oldest active truck, a 2016 F-150 with the 3.5L EcoBoost, crossed 380,000 miles last year. Original engine block, original cylinder head, 0 rebuilds. Compression readings within 9% of factory specification after nearly a decade of hard commercial use. His annual engine maintenance cost per truck, including oil, filters, and MOS2 treatment, runs at approximately $80 per vehicle per year. A comparable fleet operating in Ohio without MOS2 treatment replaces engines at an average of 180,000 to 200,000 miles. At a current installed EcoBoost engine replacement cost of $8,500 per vehicle, that fleet spends over $150,000 per year on engine replacements across a similar operation. The difference between those two fleets is $150,000 a year, and it comes down to a $3 bag of powder. Here is exactly what to do. This works on every F-150 engine, the 5.0L Coyote, the 3.5L EcoBoost, the 2.7L EcoBoost, and every naturally aspirated V6 and V8 Ford has put in the F-150 since 1990. Step 1. Get the right material. Search online for technical-grade molybdenum disulfide powder. The particle size must be labeled as under 2 microns. You will see this described as technical grade or lubrication grade on any industrial supply listing. A 100-gram bag costs between $3 and $5, including shipping. This is enough powder for 5 to 7 complete engine treatments. Do not buy the pre-mixed liquid products at auto parts stores. Those products contain MOS2 at 2 to 4% concentration in petroleum carrier oil. You are paying $18 to $35 for what is chemically identical to $3 worth of raw powder dissolved in oil you already have. Step 2. Warm the engine. Run your F-150 for at least 10 minutes before treatment. Full operating temperature is ideal. A warm engine allows the MOS2 plates to reach metal surfaces before the oil film fully builds, and the heat accelerates the tribochemical bonding process. This step is not optional. A cold engine treatment reduces effectiveness by approximately 40%. Step 3. Measure your dose. For the 2.7L EcoBoost, 6 grams of powder. For the 3.5L EcoBoost, 7 grams of powder. For the 5.0L Coyote, 8 grams of powder. Use a simple kitchen scale accurate to 1 gram. Precision here matters more than most people expect. Step 4. Mix the suspension. Pour your measured dose into a small cup. Add 30 milliliters of your current engine oil, whatever is already in your truck. Stir for 60 seconds. The powder will not dissolve. It will remain suspended as a dark gray mixture. This is correct. Do not add more oil. Do not shake. Stir slowly and steadily. Step 5. Add to the engine. With your engine idling, remove the oil filler cap and slowly pour in the entire suspension. Replace the cap immediately. This must be done with the engine running, so the oil pump immediately begins circulating the MOS2 through every lubricated surface in the engine. Step 6. 20-minute idle. Allow the engine to idle for 20 minutes without driving. During this period, the MOS2 is circulating through your cylinder walls, bearing journals, camshaft lobes, valve stems, and turbocharger bearings if you have an EcoBoost. The initial bonding begins wherever metal contacts metal under pressure. Step 7. Drive normally for 500 miles. The bonding process continues during normal operation as heat and pressure activate the tribochemical reaction across increasingly complete surface coverage. Do not tow or haul heavy loads during these first 500 miles. After 500 miles, the treatment layer is permanent. It will not wash out during oil changes. It does not degrade with heat. It does not require reapplication for 50,000 to 70,000 miles. Total material cost, $3 to $5. Total time required, 25 minutes including idle time. The equivalent dealer engine treatment service using a branded MOS2 product at 3% concentration, $180 to $350 per visit, recommended every 15,000 miles. Let's talk about what this actually means in dollars for F-150 owners. The average F-150 owner in America drives 15,000 miles per year. At that rate, without MOS2 treatment, your EcoBoost engine begins showing measurable cylinder wear at approximately 90,000 to 110,000 miles. By 180,000 to 200,000 miles, most EcoBoost engines are consuming a quart of oil every 3,000 miles and producing compression readings 15 to 25% below factory specification. At that point, you have two choices: a rebuilt engine at $5,500 to $7,000 installed, or a remanufactured engine at $8,000 to $12,000 installed. With a $3 MOS2 treatment done before 100,000 miles and repeated every 60,000 miles, total lifetime cost of approximately $15 to $25 in material, the same engine runs past 350,000 miles with compression readings within 10% of factory specification. The F-150 is America's most expensive truck purchase. The average new F-150 costs $54,000 in 2024. Most Americans finance it over 6 years. Protecting a $54,000 investment for the cost of a cup of coffee is not optional. It is the single most financially responsible thing an F-150 owner can do. The compound is called molybdenum disulfide. The formula is MOS2. It costs $3. It has never failed a single independent performance test across 80 years of documented use in military, aerospace, and commercial fleet applications. The only reason most F-150 owners have never heard of it is that knowing about it costs the wrong people far too much money. If this video opened something for you, share it with every F-150 owner you know. The repair industry spent decades making sure this information never reached the people who needed it most. Every share puts it in front of someone they assumed would never find it. Subscribe and hit the bell, because next week I'm going into the $4 fix that every F-150 EcoBoost owner needs to do before the turbocharger fails, and why Ford dealers are legally prohibited from recommending it even though they know it works. That one is going to be uncomfortable for a few people in Dearborn, Michigan. I'll see you there.